Welcome to Everyday Spacer. I'm Jeff Miller, CME Computer and IT Solutions. Pam can't join us tonight because she's not feeling well. Nothing tragic, just cold or flu or whatever it is. So just we wish her well, but she won't be joining us except maybe in the comments. At Everyday Spacer, we show regular folk how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific time, 12 midnight Eastern time, and 3 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California, tonight I'm broadcasting live from Thousand Oaks, California, and thank you so much for being here. And let's see, Quagmire 3. I don't recognize that handle. I heard today that they ended the Farmer's Almanac and that 2026 will be the last issue. It was such a helpful reference. I was buying them in the 70s and 80s to help with garden planting times. I hadn't heard of that. Maybe Pam had. That's really disappointing if so, because we get a lot of our ephemeris information from there. Hi, Cliff. Glad to see you here. Hey, yeah, me too. Healing prayers for Pam and hi, Janie. Yep. Oh, hi, Scott. Okay, so now I know what handle you sometimes use. I guess the S on there should have been a clue, but don't always know because so many people have the same first initial. Thanks, Janie. It's really sad that it's going because it was a really handy reference. Okay, cybersecurity news. Not much going on. There's some industry software that could use updating, but not much there. Apple products, update Apple products because they found a vulnerability in there, and most Apple OSs need, iOS, Mac OS should use an update. So if it hasn't called for it already, and by called for it, I mean, last week or the week before, because they usually give these announcements after people have had time to download the updates for a while, just to not alert the bad guys that there's an issue for them to find. Hey, Don. Welcome. So we are, another piece of cybersecurity is we're doing a Zoom webinar November 19th at noon here Pacific time, go over current cybersecurity events and do a Q&A. I know Janie's been there, and I've been talking. I'll be going over a bunch of people that have been hacked either through cybersecurity events or phone or just regular scammed over the phone that led to that can lead to cybersecurity. And one thing that comes out, and I'll mention it here, but I'll go into it more on the 11th or on the 19th, is someone got scammed because they asked Siri for a Microsoft tech support, and Siri gave them the number for a scammer, because anyone can mess up search results. You can temporarily get yourself really high in the search results without too terribly much effort, and then it'll go away soon. Or you can do a sponsored ad, and that shows up at the top of the search results. Now, in a regular Google search, you can see that. And you can see that, tech support number is from a website that has nothing to do with Microsoft. But when you use Siri, Alexa, or any of those other ones, verbal ones, you don't, you can't see that. So those references are blind. You can't see the source of what they're giving you. So do not trust phone numbers, or don't trust stuff like that from anything that's just giving you a verbal response. Always look it up, because you just can't check it. And since the bad guys have found a way to mess with it, so if you want an invite to that webinar, just email me at jeff@cme.com or cmeit.com, and I will get you on the invite list for that webinar. Like I said, there's 4 different things to talk about from people who've actually told me stories over the last couple of weeks. Hi, Naomi. Welcome. If you came in late, Pam won't be here, Naomi. So it's me. You're stuck with me. Janie says a 208-year run for Farmer's Almanac ends due to financial challenge and changing reader habits. Guess there's not enough of us faithful readers. Yeah, it was great, so great for so long. Yes, it was. Even if they could have afforded to go all digital, that would have been okay. But if they're only ending the print version, that's not great, but it's okay. If they're basically closing the doors completely, yeah, oh well, it's a great resource. Okay, so tonight's topic is asteroid image checker. Help us measure how fast asteroids rotate. And hang on while I get, there it is. We'll be back in 8.3 seconds. As soon as I find it. Where is it? There's intro, outro. Where is it? We'll be back in 8.3 seconds after something. There it is. There's a link to that book in the description. If you want a signed copy of the book, write here. Write to pam@everydayspacer.com for details. Can you all tell who generally runs this part of the show? Cliff. Yeah, Cliff. Fortunately, some of them have made the transition to digital, although they tend to end up a bit more clickbaity than they used to be. You don't get the number of articles that you used to get. But yeah. So tonight's episode is a citizen science project hosted on Zooniverse. Their science team says asteroids spinning in just seconds or minutes challenge our understanding. The rapid rotations should tear apart the fragile structures needed to explain their unusual behavior. And that's what they say, and that's how they bill it. However, the task is not to determine how fast the asteroids are spinning. Our task is to identify which images actually have asteroids in them, or actually more specifically, which have clear images of asteroids in them. They're looking for anything that has asteroids but no other noise. So the science team can determine basically how big the asteroids are and how fast they're spinning without any interference in the image. And oh, I guess I should share the screen, huh? Pam's probably sitting back there cringing right now, but oh well. You get to see what Pam deals with all the time. There we go. Okay. Here. Here we go. Let me see everything here. Yeah. Sorry, I'll get this squared away soon. I promise. Okay. There we go. Okay, so here is the Zooniverse asteroid checker. And this is a relatively easy one. And this number is up from 0. It used to be 0 completed subjects. And it's a relatively easy one that you can just bip through fairly quickly. It not quite counting craters, but you're so it's not as tedious as counting craters, but it does go through them fairly fast because you're looking for specific things. So this is the quote before, and they're talking about, you know, what asteroid rotation is and stuff like that. And they're selling all of the asteroid spinning stuff, but your job is to point out the ones that are spinning. So let us go here and get into the get started. And you see a video that is 2 to 4 frames to watch the asteroid move. That way you can spot which one's the asteroid. And then and then you're looking for other things. So the asteroid, I don't know why they care so much that there's an asteroid in there, because that's not what you're looking for. But this is, you can see the asteroid moving. But one of the things that you look for are weather effects, like all of this here, which they include things like if there's condensation on the lens or something like that. So anything that messes with the image like this is what they call a weather effect. So once you've identified the asteroid in the video, look at the same object in the image and select one of the provided options. Here we go. And this is cloudy conditions. It'll appear as distinct dots. Don't know why, but that's just the way it resolves in their cameras. And that's a satellite trace. But note that even if the satellite is nowhere, say the asteroid's over here and there's no way it crosses that trace, if there's a satellite trace, you mark it as such. I guess they just don't want anything to interfere with the general brightness level of the image itself. Also, if it's really close to a star, they don't want it because the light level would interfere with it. So basically, if the star is within 3 apparent diameters of the asteroid, and they call it angular diameter because just how wide it looks. So within 3 diameters of the apparent diameters of the asteroid, they don't want the image because I guess there's too much light pollution to get the measurements that they want. And this is an example of, there's a star right there and there's the asteroid. They're really close together. The asteroid appears big because it's closer. The star appears small, but it's within 3 diameters of the image, which means that you might need to zoom it to see that. That's the only tricky thing about this whole thing. So this is a good image. There's the asteroid. There's nothing near it. So there's a field guide. It pretty much tells you the same thing. So there's not much to go. They have more examples of it, but quite frankly, you guys know what a satellite intrusion is. Bad weather, they specifically say things like this are also included, which I think is condensation, or it's just a really small cloud. But anything like that any fuzziness is just mark it as bad weather. Star interferences, same thing that you saw before. Whoops. If you scroll down too much, that goes funky. So let's look at the about, the research team, or the research. And here they're talking about who are the enigmatic visitors to our planet's neighborhood. Most orbit in the main belt. These basically dip in closer. And that's probably why they're spinning so much. And they do explain that. However, but they can only spin so fast or they'll break apart. Or at least so we thought. Because they're finding ones that are spinning faster than that. So they want to figure out how and why they're spinning that fast. And so they need a bunch of them in order to figure that out, because just a couple data points, you can have like the fewer data points you have, the more explanations you can have. So they want enough data points that they can rule out some explanations. Yeah, Cliff. It's not that hard. The only tricky thing is with the stars, and you might need to zoom in. But so, the old, and they're talking about the Yarkovsky effect, where the sun heats it, and they're not even talking about outgassing like on an asteroid. They're talking about photons coming off of it. The hotter it is, the more photons come off of it. And so that produces not much thrust, but it produces some. And this is the Yarkovsky force. If you notice, the side away from the sun produces fewer photons, heat, because radiated heat comes off as infrared rays, which are low energy photons, and there's more of them when it's hot than when it's cold. And so that produces some thrust. And if there's already a little bit of rotation happening, it just spins it, makes it faster and faster. And how do they determine the rotation periods? Because they're not spherical, so they can tell, if it's more bright or less bright, just because the shape is not spherical, so it gets wider views, narrower view. And this is how can we help? Well, we can we can just basically determine which are good candidates for their study. And they've done 3 papers on this. So, and I'll look at them, but you can find them here. I'm not going to read them to you because they're a little bit dense, and that's just takes a long time. The team, not a huge team. 3 people. 3 main people plus the usual people from Zooniverse, helping. They've got some translators here, and Belgrade. So it looks like this is a Belgrade University project. The results. And again, they talk about the papers. And at this point, I believe that they're just discussing the Yarkovsky effect, not necessarily why the things aren't breaking up yet. I don't know that they've gotten to the point where they can even make some good guesses about that. But the more stuff we have on their spin, the better they can, the better data they can have to solve that. And education, they've got a good video here. I'll show it to you right here. This is the spin. And if I leave the mouse alone, the perspective doesn't change, but the perspective changes with, you can see the sun there. So the sun side, and it just causes causes the asteroid to spin because it releases more photons when it's hot than when it's cold. So that's that. And if you care, here's one paper, two paper, three paper. So these are the papers that they've got. So that they measured the Yarkovsky drift and basically showing that it can be thermal conductivity. So they've gotten some stuff from it. The fact, not quite. Why do they call it enigmatic visitors? Well, because they're spinning weird, which is why they consider them enigmatic. But they're also dipping in out of the asteroid belt. What are the rotation periods? How the contribution basically lets them get good data, good candidates for their data. So let's go back to here. And so this is the task. And here we can run the video. So we can spot the asteroid. There it is. Now this is the image. So now that we know the asteroid, I believe that this is the asteroid. So let's see. There. Yeah. So the asteroid ends up here in the image. So this is the asteroid. And we can see that there's a nearby star, but it's not within 3 diameters of the asteroid. So this is a good image. Done. And then we can talk about it. Not much to say. So we'll just hit next. And another one. This looks surprisingly similar to the previous one. I think it's the same drill, but oh, I see. This is the same path, but it's one of the other images from that. And again, a couple of stars nearby, but not within 3. So we'll call that good. And remember, even if you make a mistake, these are, there's multiple people. Okay, same one. So it looks like we're this batch. I'm going to see all of these. And the only one that we'll probably not be able to do is when it's really close to the star. So here it is, nothing nearby. It's a good image. Let's see where this one is. Okay, same one. Where is that? Where did it end up? Maybe here. Yep. Oh, right there. That's where it is. Okay, nothing nearby. Good image. I was hoping to get something from another batch. Oh, here we go. This one's different. Right there. Now this must be relatively close because it's really big in this image. So let's see, where is it? Okay, nothing nearby. Good image. Okay. Well, that's enough of that. As you can see, not much to it. I didn't even get any good satellite intrusions or bad weather, not even star interference because there weren't any stars nearby. But that's that. We also found a couple of other things. One of them is someone is talking about, oh no, Atlas, 3i Atlas broke up, and they're such a loss and all of this stuff. It's behind the sun. There's no way to see what it's doing right now. So, in fact, a lot of the comments in here talk about that very thing. So, there's a lot of clickbaity garbage articles out there. So just be careful. I looked at some of the other things that these guys have. And fact fusion, yeah, they fuse fact with clickbait, or fact with drug use, I guess, because they take a fact like there is a comet 3I Atlas and make stuff up about it. So just be careful about stuff like that. I hear Pam laughing back there. Okay, Artemis, send your name around the moon. She's going to do this. I don't know her pin code, so I can't demonstrate it for you. But hey, if you want your name, on board a vehicle that's going to go around the moon, it's real easy. Go to NASA, send your name with Artemis. Back up. That's easy enough. Let me just post that in the comments. In fact, as long as I'm at that, let me, here. Let me get this. Let's go to the top here. Easy enough to find, but why go through all that work if you don't have to? And, oh, yeah. Cliff. Yeah. The comet has 3 eyes. Yes. Oh, don't say that. Someone's going to write an article. Probably those bozos. But, whatever. So let's come back to me. There I am. Okay. Yeah. Okay. So, Pam likes to say Everyday Spacer is sponsored by CME Computer and IT Solutions. Sounds a little bit self-serving for me to do it, but that's where it is in here. Just if you have any questions, you know how to reach us. I can answer some questions for you. Okay. Also in here, let's see if I can find it again. There is a globe at night, new globe at night, and November. Oh, am I showing? Oops. Hang on. Yes, I am showing. Okay, good. Here we go. In the southern hemisphere, look for Grus, and in the northern hemisphere, look for Perseus. And you won't see those images in the sky, just the stars. But go outside, take a shot with your phone, upload it, or compare it. Use the app, the Globe at Night app on your phone, and help them map out the dark skies. And Cliffs has another. Here, let's just go back to me. Cliff says, Selena said that first. Okay. Oh, Sabina said that first. Okay. Yep. Okay. And my notes. There they are. Okay. The 3 eyes. I get it. Sorry, I get distracted with what I'm seeing here, Cliff. Some stellar events this week. November 7th through November 14th. November 8th, the moon rides high. And Mercury is 2.6 degrees north of Antares. November 9th, Mercury appears stationary. They always say Mercury is stationary. No, it's not. It just appears stationary. November 10th, Jupiter and the moon are in conjunction. And Pollux is 2.7 degrees north of the moon. And Jupiter is 0 degrees south of the moon. Yeah, I get that, Cliff. And I'm distracted, which should come as no surprise to those who know me. November 11th in the U.S. is Veterans Day. U.S. and in Canada, it's Remembrance Day. I think in Australia, I think you guys are having yours on Sunday. So that would be, let's see, the 9th. And the globe at night starts on the 11th. So, the globe at night that I talked about is 11th through 20th. And I already talked about it. November 12th is a last quarter moon, and Mercury and Mars are in conjunction. Mercury is 1.2 degrees south of the moon. Also, North Taurid meteor shower peaks. Look east after midnight. Oh, well, that makes it easy to remember. Yes, thanks, Janie. Yes. Yeah, Janie says, blessings and gratitude to all veterans and service members and families. Yes, I wholeheartedly agree. And we have something else to show you. Let me get back to it, because she has meteor showers. So, meteor shower calendar from almanac.com. North Taurids is a smaller but steady annual shower. Pam likes to call it a drizzle, not a shower. Produces only a few meteors per hour. What makes it special is that the meteors are often bright fireballs that streak dramatically across the sky. So that might be worth seeing. Instead, if they're much brighter, it might make up for the fact that, oh, and the moon's 76% full, which makes it a little bit hard to see them. But maximum is November 9th. Peak per hour is 3, which means roughly 20 minutes between different ones. So, yikes. Associated comment NK or NK. And so not good viewing, but watch it late evening. Point of origin is to the south, and I believe my notes say look east after midnight. So let's come back to us, or me. I'm used to saying us. So also on the 11th or 12th, also on the 12th, Regulus is 1.1 degrees south of the moon. November 14th is our Friday night show. Pam will profile Margaret W. Rossiter. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. And let's see. Oh, if you or someone has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, November 14th, profiling Margaret W. Rossiter. And I don't know who that is, so hopefully Pam can tell us about her. Well, thanks, Janie. We like finding interesting people to profile. And thanks, Don. Yeah, and with any luck, Pam will be much better. With any luck, Pam will be better tomorrow. But so Pam should be here for the show. So that next week. So that'll be good. So thanks, Jeff Sparkle. Yeah. Oh, I think you might have scared Pam. Okay. Yeah, and you take care of yourself, Cliff. Thanks, Scott. I managed to muddle through pretty good. Um, Hit all the high points, and the computer is still intact. So, yay me. So, I will see you guys all next week. Good night.